So here we go. So number one, we're going to graph. So today it is review 3/21st day of spring. I like that.
Wait, it's not the 21st.
It's the 20th. 20th, yeah.
Yeah. Wait, when's spring break?
First day, I said 20th, first day of spring. Today is the first day of spring. The equinox occurred sometime today. I just don't know when. Okay, number one, I'm going to graph it. So let me, first of all, I know it has to go through 6. So when I go ahead and make my graph, I'm going to make sure my graph goes through at least at 6, okay? And this is important. When I look at these graphs, I don't need everything to be perfect, but I need a couple of things to be really good. First of all, it has to go through 6. So I've got to make sure 1, 2, 3, 4, 5, 6. It's got to go through that value right there, okay? If there's no value there, then it's a 1, correct? Now, this is 0.5, so it's half of 6 is 3. Half of 3 is 1.5. Half of 1.5, and so forth and so on, okay? Now, I need this shape right here. It has a horizontal asymptote at y equals 0, okay? It is decay for 2 reasons. One, it is getting smaller and smaller, but the reason it's getting smaller is because the base is less than 1. If the base is less than 1, it's going to decay. Okay, number 2 is going to be growth. So what I'm going to do first on number 2 is try and graph it. It's got to start at 4, but then it's going to go up from there. So I'm going to go ahead and give it some more room. Let's see how much can I give it. Oh, that's probably pretty good right there. It's going to start at 4. 1, 2, 3, 4. It has to go through at 4, okay? And then to get a little bit accurate, I'm just going to use my calculator if I want to get a little bit accurate, okay? So I'm just going to go, I'm just going to go clear. If I go 4 times 1.2 to the 1 power, right, to the 1 power, I get an answer of 4.8. So I'll have a value at 1 and 4.8, so I'll guesstimate 4.8. I'll go 4 times 1.2 to the 2 power, and I get an answer about 5.76. 1, 2, 3, 4, 5.76, maybe up there. I'll try 3. I'll go 4 times 3. Oops, I'm sorry. 4 times 1.2 to the 3rd power, and I get about a 7. 1, 2, 3, 4, 5, 6, 7, and it slowly curves up. So I know the graph is going to look something like this, okay? And this is definitely growth for 2 reasons. 1, it goes up, right? And 2, the base is greater than 0, okay? Thumbs up?
No. Yes.
I'll wait for you.
Do we put an asymptote in?
Yeah, the asymptote is still down here.
Do you want us to put it?
It's always nice to have it. I won't count it wrong if you don't, but the asymptote is at y equals 0, right? Domain is all real numbers, right? And the range is y is greater than 0. I might ask that question. Okay, you ready for number 3? Renee, you ready? Okay, slide number 3. So, number 3, what is... Oh, I'm sorry, Katie. So we want to graph 3 and its inverse. So let me go ahead and go to number 3. I have a y equals 5/3 x minus 4. Okay, to graph this, right? I know it's a straight line, it's linear. I'll do this one in green, okay, and I'll start at 1, 2, 3, 4. Slope is up 5 over 3, up 5 over 3, 1, 2, 3, 5, 1, 2, 3, and so I know it's a linear equation, so it's a straight line. Okay. There's the original function, and I want its inverse. Now to do its inverse, we need its inverse graph and its inverse equation. So we're going to do both. So first of all, I want its inverse. I'm going to take all of these points and just switch them. This is the point at 0, -4. This is the point at 3, 1. So to get its inverse, we just flip-flop them, right? So we'll have an inverse point at -4, 0, 1, 2, 3, 4. And I'll have another value at 1, 3. 1, 1, 2, 3. So its inverse is this graph. That's my inverse graph. I just switch the points around, right? So this is at a -4, 0, and this is at a 1, 3. Okay, how am I doing? So far, so good. So to get the inverse, you just switch x with y's, right? Now, if I need the equation, then I have to switch x and y, okay? So I need the equation of the inverse. We're going to switch the x and the y's. So we're going to go x equals 5/3 y minus 4, okay? But I want to solve for y, so it's in the correct form. So let's solve for y. So solve for y, I'm going to go +4, so that x plus 4 equals 5/3 y. Multiply by 3, that's the easiest thing to do. Multiply everything up by 3. I'll multiply the 3 up here. So I will get a 3 times an x plus 4 equals 5y. And then I'll divide by 5, and I'll get 3x plus 4 divided by 5 equals y. That's the inverse, so I'm going to rewrite it as f inverse. I'm going to rewrite as f inverse of x equals 3 times x plus 4 over 5. And yeah, if you want to multiply it through and simplify it more, you can. That's just a really nice, that's just a nice, tidy version of it, okay? Okay, guys, thumbs up? No, okay, I'll wait for you.
Is the range for number 1 x is greater? Is it?
Yeah, x is greater than 0, yeah. For number 1, yeah. X is all real numbers for number 1. X equals all real, and domain y is greater than 0, yeah. Okay, you guys ready for, Natalie, tell me when you're ready for 4. Okay, you guys ready for 4? Okay, so number 4, it does say graph, so we'll graph it, right? Okay, so the points I need are at, can you see that? No, you can't see that. Hold on, let me get so we can see it. Otherwise, I'd have to zoom again. Here we go. There's number 4. So let's graph -2, 0, -1, 2, 0, 4. Uh-oh, run off my paper. That's all right. 1, 4, 1, 6, 1, 2, 3, 4, 5. Hold on. 1, 2, 3, 4, 5, 6, and 2, 8. I'll put it up there. 1, 2, 3, 4, 5, 6, 7, 8. Okay? All right, that's all I did. All I did is just graph those points, right? Now the inverse is just going to be the opposites, right? So the inverse, instead of the point at -2, 0, at -1, 2, 0, 4, 1, 6, and 2, 8, the inverse is going to be at the opposites, right? At -2, 0 would be 0, -2. -1, 2 would be 2, -1. 0, 4 would be 4, 0. 6, 1. And there's the other, okay? That's my inverse, okay? Davies, yes.
So confused.
Okay, so you see how I graph these points, right? Natalie, it's as easy as this, honest. When I say it's easy, believe me, okay? All I'm doing is switching them. This becomes 0, -2. This becomes 2, -1. This becomes 4, 0. We just switch them. That's all we do, switch y's with x's. So when you get that graphed, all I'm doing is change them. So this becomes, I can even write them up there if you want to, 0, -2. This becomes 2, -1. This becomes 4, 0. This becomes a 6, 1. And the last one is my 2, 8, which is off my paper, but 2, 8, 2. I'm sorry, 8, 2. So you're just switching x and y's, inverses. That's all you do for an inverse, switch x and y's. Okay? Now, it says domain and range. Well, the domain and range of the inverse, so the domain of the inverse are the y values. So the domain is just this set 0, 2, 4, 6, 8. And the range, because you're switching the x and y's, the range is just going to be -2, -1, 0, 1, 2. Okay? The x's become the y's, the x's become the y's, and the y's become the x's. It's that simple. Amber, why don't you put your phone away for me, please? All the way away. All the way away. There you go. Thank you. All right. Let's go to number 5. We actually have done number 5, and I'll put it back up there. We already did number 5, and it was the f inverse of x, because it's the same one as this one, right? Is equal to our 3 times our x plus 4 over 5. We already did that inverse. We did the work in number 3, okay? All right, we already did this answer. We did this answer up in number 3. Okay, so that is the inverse equation. So when we switched x and y and we solved. Okay, you guys ready for 6? Okay, 6 is easy. We're going to rewrite as a log. So we're going to use our rule. We're going to go log of base 5 of 125 equals 3. So we're using these rules. We're going from exponential form to log form, okay? That's all we're doing. Okay. And I'll leave that on the board for tomorrow. Okay, 7, we're going to go the other way, okay? We're going to go from log form to exponential form. We're going to go 2 to the 5th equals 32. That's all we're going to do. Stephanie, you writing this down? Okay, number 8. Because it's base 10, we can go straight to using our calculator. We're going to rewrite it, though, as log base 10 of 1,241 equals x. And because it's base 10, we can use our calculator, okay? So if we use our calculator, clear, I'm just going to go log. It has the invisible base of 10 of 1,241. And I get about a 3.09. Okay. Number 9, I'm going to need a little bit of paperwork, so I'm going to move it over and put it on another piece of paper. So number 9, I'm going to scoot this away. I'll do 9 here because I'm not going to have room for it. But 9 is my 5 to the x equals 54. Okay, this is like our warm-up, right? Remember the warm-up? You can't solve for x when it's in the exponent. So to bring the x down, we have to take the log of both sides, okay? So I'm just going to go the log of both sides. I'm going to log of 5 to the x equals log of 54, okay? So then the x can be brought down. That's our log rule, okay? So we take the log of both sides to bring the exponent down. So we rewrite this as x times our log of 5 equals our log of 54. You don't need the parentheses there, but I like the way Tammy did it because Tammy put the parentheses in here earlier, and that you knew that meant multiply, right, Tammy? Okay, we got to solve for logs. We can solve for x by just dividing by log of 5. Divided by log of 5, and just use your calculator, okay? So what is log 54? Okay, clear. What is log 54? Close your parentheses. Divided by log 5. And I get an answer of about 2.478. About 2.478. Okay. All right, let's take a look at number 10. Okay, number 10 again is like our warm-up, one of the ones we did. Okay, number 10, I'm going to rewrite it down here so I've got room to work. I've got log of base 2 of x equals 1.2. Okay, solely your calculator won't do this one because it's an x, right?
Yeah.
But that's okay because solely's going to go and change it to exponential form. 2 to the 1.2, 2 to the 1.2 equals x, okay? And what is 2 to the 1.2? I don't know. It's a calculator for. I don't know. What is 2 to the 1.2 power? About 2.297. About 2.297, okay? Doing okay? You gotta be careful with rounding, especially with logarithms, because logarithms come from exponents. If you round too much, you start to really change the answers, right? That's why I always like to go a little bit more on my logarithms, okay? Okay, number 11. Let's check out number 11. We've got log x equals 4. Okay. We are missing an invisible base. What's our invisible base? Okay, so we're going to go 10 to the 4th power. No, it's 10,000, but you got the right idea, okay? Equals x, because 10 times 10 times 10 times 10 is 10,000. Okay?
Or the amount of force coming through. The amount of exponents is how many zeros.
Always in 10. And that's one way to prove that anything with the 0 power is 1, right? Yeah. Amber? Oh, Amber, let me borrow your phone from ya. Come on, hand me your phone. I'll get it back to you later. Miss Amber. All right, there we go. Let's keep filming. Okay, let's look at number 12. All right, 12 is log base 2 of 2 to the 7th equals x. Okay, now, a couple of things. First of all, I'm going to go 2 to the x, 2 to the x equals 2 to the 7th. Or we would have remembered a rule that I gave you, that these two will cancel each other out, right? Or we already know x is 7, right? You guys agree x is 7? That just proves the rule right there, doesn't it? X equals 7.
Or you can solve it. That's easy.
Or you can solve it. Yeah. Okay, 13. I'm going to need to put 13 on another piece of paper. Okay, 13. Log. Okay, you ready? Here's one that you guys are saying, okay, log base 2 of 64 plus log base 2 of 4 equals x. Okay? Now first of all, because of the plus, I need to combine it as a single logarithm. So I'm going to rewrite this as log base 2 of 64 times 4, okay, equals x. So I got log base 2 of 256 equals x. Thanks, Renee. And then I'm going to go, okay, 2 to the x, right? 2 to the x equals 256. So let's see, let's figure it out, okay? Let's go through our heads, okay? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is, so we can check it. I think x is 8. I can check it. X equals 8, but I can check it on my calculator. Well, let's see, is 2 to the 8th power. Yeah, we got it right. 2 to the 8th power is 256, right? Yeah, nice. 8 it is. Okay? Or here's another way. This one's going to be a 6, and that's a 2. Do you see that, Claire? 14. All right. Log base 4 of 64. 64 minus log base 4 of 4 equals x. Okay, two ways to do it. I'm going to do it both ways, okay? Okay, I do know that 4 to what power equals 64 has to be 3. This has to be 3. 4 to what power equals 64 has to be 3. 4 to what power equals 4 has to be 1. I know the answer is 2. Boom, that's one. That is one way to do it, okay? 4 to what power equals 64? It's got to be 3. 4 to what power equals 4? It's got to be 1. That's one way to do it. The other way is I'm actually going to combine them, okay? Or you do the log rule, which is log base 4 of 64 divided by 4, okay? The subtraction makes the division, okay? All that equals x. So I can change that to 16, right? 64 divided by 4 is 16. So I go log base 4 of 16 equals x, because that's 16, right? I'm going to go 4 to the x, 4 to the x power equals 16. Well, it's got to be 2, right? 4 squared, x equals 2. All right, we're getting there, huh? You guys ready for number 15? Okay, this is not that bad, is it? Okay, well, you guys haven't been doing your homework. That's why. Let's be honest, huh? We're being honest. 15. So, log base 5 of 1,000 equal... Oh, is it 100? Thanks, Katie. Oh, that looks terrible, Katie. Let's do it all over again. Log base 5 of 100 equals x. Okay, so unless you have a fancy dancy calculator, like some people, we got to do it the long way. We got to go 5 to the x equals 100, okay? Okay, we got to get x out of the exponent. How do we do that? How do we bring x down? We log it, right? We take the log of each side, so we'll go the log of that and the log of that. So then we'll get x times the log, so log of 5 equals log of 100, right? Divide by log 5, divide by log 5. Okay? So we'll do log 100 divided by log 5. We'll find out what that is in a second. How about 2.861? 2.861. How am I doing? Okay. 16, and then we're going to get to the hard one, okay? 16, we've got log of base x of 125 equals 3, okay? So let's go x to the third power, right? X to the third power equals 125, okay? Now it's old math, because we're going to cube root it. We're not going to log at all. We aren't going to log this one because we already know the exponent's the number, right? We take the cube root, and the cube root of 125 is 5. Okay, let's do the hard one. You ready? All right. Tell me when you're ready. We're going to do the hard one, okay? Okay. 17. All right. So a quantity of medicine used breaks down in the body 10% every minute. If the initial amount is 50 grams is taken, find the following. Okay. An exponential model to model this. Okay. So we're going to start off with 17. We're going to do this. We're going to go our f of t equals our a times 1 plus or minus r to the t power. Remember that formula?
No.
You don't remember that formula?
No.
Well, it was on the board for a long time.
I remember it.
It was on the board for a long time. Yeah. It was on the board for a long time. That's okay. Now, do you remember it now? Okay, well, all right. So anyway, let's start with 50. So f of t equals 50, right? And it breaks down, so 1 minus, now 10%, we use a 0.10, right, to the t power. Okay, there's my equation. There's my equation. Okay, thumbs up on my equation. Okay, now, how much medicine remains after 15 minutes? So let's let t equal 15. There's A. So for B we'll go, all right, f of 15 equals 50 times 0.90 to the 15. I just changed that to 0.90, right? You know, right? And I need my calculator. Okay, if I need my calculator, I'm just going to do that. All right. Hold on, let me put the answer in. I'll scoot back. 50 times 0.9 to the 15. I get an answer about 10.3. Okay, so I get about 10.3. Is that milligrams? Grams. Okay, Renee, let me know when you caught up, okay?
Mr. Davis, why did you switch it from a 10 to a 0.9?
Oh, because I just went 1 minus 0.1 is 0.9. You can leave it like this, Avi. Don't even bother with this. Just put the 15 there. Right? I mean, you get the same answer, right? I just simplify. You do not have to do this to this. I just did it, right? Yeah, I knew you would. Okay, Renee, you ready for C? Okay, let's look at C. Okay, C says, how long does it take for half the dose to remain? Okay, so half the dose. We start at 50, so let's set at 25 is equal to, you ready? 50 times my 1 minus 0.10 to the t power. Okay, we got to solve for t. All right, we got to solve for t. So AV, this time I'm definitely going to change that to 0.9. Okay, make it easier. So let's go 25 equals 50 times 0.90 or 0.9 to the t. Okay, just simplify it. Now let's divide by 50. Divide by 50. Yes.
Wait, shouldn't T be 15?
It was here. Yes. For B. Yes.
Why is it 5?
Okay. Now for C, we want half. Half.
Oh, okay.
You got it? Half. Okay, now I got to solve for t. Let's divide by 50, divide by 50, and I get 1/2 equals 0.9 to the t. Okay, now how are you going to solve for t? How are you going to solve for t? Yeah, take the log of it, right? Log of both sides, log, log. Take the log of both sides, log of both sides. So I'll have log of 1/2 equals t log of 0.9, right? Divide by log of 0.9. And let's see what the calculator tells me. Log, clear, clear, clear. Log 0.5 divided by log 0.9. And I get an answer of about 6.5, 6.6. About 6.6. Is that in hours or minutes? What is that? Minutes. Okay. Now, to graph this. Now, the graphing this is not difficult because we're going to take what we know, okay? We've got some information to graph this. We've got a point here, okay? And we've got a point here, okay? And we even have a beginning amount, okay? So to graph this, it's really not going to be that difficult. So watch me graph it. Okay, let's take what I know. Okay, so I grab my graph paper to graph this. And I'm going to graph f of t equals my 50 times my 1 minus my 0.10 to the t power. Okay, so let's see what I know. There's a few points. I know the start is at 50. Okay, I know that, right? I know that right off the bat. Okay, I know that after 15 minutes, so we'd have a point 15 comma, we'd have 10.3. Okay, that's part of what I have from what I just discovered, right? I've just taken the data I just figured out. Okay, I also have a point at 6.6 minutes and 25. Okay, that's another point I have. So I have a start. I got 3 points, and that's enough to graph it. It really is. So to graph this, let me go ahead, and I know I got to go all the way up to 50 to begin. So I'm going to go ahead and make sure I get up to 50, which I may have to go by 5s, right, to get 50. So I'm going to go ahead and if I put my graph. Go. So let's see, is this going to work? 5, 10, yeah, this will work.